One application of separation of variables is solution concentration problems. The concentration of a solution over time can be expressed as a differential equation. The flow rate of the solute, U, which we will denote du over dt, equals the inflow rate minus the outflow rate. For example, imagine a tank containing 75 pounds of sugar in 600 gallons of water. A sugar solution is being pumped in at a rate of 6 gallons per hour. The sugar solution has concentration of a quarter pound of sugar per gallon. The tank is being drained at the same rate as it's being filled, so the liquid stays at the same level. If we assume the tank stays well mixed, we can find the function of u of t to describe the sugar concentration at a particular time. We start with du dt equals the inflow rate minus the outflow rate. We know from the problem statement that the inflow rate is 6 gallons per hour, and we multiply this by the concentration of the sugar that is flowing in, which is a quarter pound per gallon. We also are told that the inflow and outflow rates are the same, so outflow is 6 gallons per hour, and this is multiplied by the current amount of solute in the tank, which is U pounds over 600 gallons. Simplifying, we obtain du dt equals 1.5 minus U over 100. Combining the fractions reveals du dt equals 150 minus U over 100. We start with our combined equation, which is du over dt equals 150 minus U all over 100. From here, we want to separate the variables, so we have t on one side and U on the other side. Separating the variables, we have 1 over 150 minus U du equals 1 over 100 dt. Now we need to integrate both sides. So we have the integral of 1 over 150 minus U du is equal to the integral of 1 over 100 dt. After integrating both sides, we obtain the negative natural log of the absolute value of 150 minus U equals t over 100 plus c. To get rid of the natural log, we'll raise e to the natural log of the absolute value of 150 minus U, and do the same to the other side to get e to the negative t over 100. Notice that we moved the negative sign over to the right-hand side of the equation. We will also need to redefine c. This gives us the absolute value of 150 minus u equals c sub 1 times e to the negative t over 100. Now, we want to find the function for u of t. We'll need to rearrange our equation to do this. Rearranging the equation results in u of t equals 150 minus c sub 1 times e to the negative t over 100. We must solve for c sub 1 using our initial conditions. We know that u of 0 equals 75 pounds of sugar. Substituting in 0 for t in our equation, we get u of 0 equals 150 minus c sub 1 times e to the 0 power. Plugging in 75 for u of 0, we get 75 equals 150 minus c sub 1. Solving for c sub 1 gives us c sub 1 equals 75. Now we can write our final equation for u of t. The final equation is u of t equals 150 minus 75 times e to the negative t over 100.